right, whether you're ready or not, we are going to move on a little bit. We're going to get into simplifying, multiplying, and dividing with square roots. Okay. The big thing, and some of you have kind of picked up on this as I've talked to you, as you've asked me questions, we don't do anything with decimals in here. Okay. Everything is in simplest form that is exact. Right? Because like if you had something that was 1/3, what is that as a decimal? 0.3 repeating forever and ever and ever and ever and ever, right? That's not exact. If I'm doing calculations with that and I'm like trying to write down 0.3 repeating with a whole bunch of 3's, can I ever write all the 3's it's going to be? No. So 1/3 is exact. Same thing with radicals. We will not switch like square root of 13. Is that nice and pretty? No. It's going to be some ugly decimal, but we don't do decimals. You're going to write it as a simplified radical, so it's an exact answer, okay? So everything in here is going to be simplified radicals or fractions, everyone's favorite, okay? We do not deal with decimals in here. All right, so for today, the only part of this I'm going to talk about is just how to simplify a square root. That's all we're going to talk about today, okay? We'll worry about the other stuff later this week. So if b squared equals a, then b is the blank of a. What do you think? It is the square root. Yeah. Right? There's even a picture right there. Square root. So if, with the example of 3 squared equals 9, then what's the square root of 9? 3. Right? It's just a number that multiplies by itself to give you that number. Do all numbers have a nice, pretty, perfect square root? No, actually most of them do not. Do you guys know what symbol is used for the square root? What a radical symbol looks like? Right? He did it right there in the air. It's like a little check mark with a line over top. All right, an expression containing a square root is simplified when all perfect square factors have been removed out of it. Now, how many of you have learned in the past how to simplify a radical? Has anybody? A couple of you? Those of you that have learned, did you do factor trees or a different method? Yeah. Did you do factor trees? Okay. There's more than one way to do these. If you do them a different method than I'm teaching you, totally fine. I'll be honest with you. In my head, when I do square roots, I do them a different way. But I found that students understand them better with the method I'm going to teach you. Okay? And actually, we do this like all semester long, and it's amazing how fast people get at doing these. All right. So moving on. How do we do this? So I broke it down step by step for you. So first thing you'll do is create a factor tree to find all the factors of the number. Factor trees I know feel very elementary, right? You do those when you're really young, factor trees, but they are so helpful. So like first thing though, obviously square root of 24, I would want to ask myself, is it perfect? Because sometimes they are, and then people get thrown when they do the factor tree when they didn't realize it was perfect. But we know it's not. So factor tree, in my example, I went 2 times 12. 12 breaks down to 2 times 6. 6 can break down to 2 times 3. We keep going until we get prime numbers. What's it mean to be prime? Very nice. That's like a perfect definition. It's not divisible by anything but itself and 1. Right? Like 2, it's just 1 times 2. Like it doesn't really go anywhere else. So I'm going to highly recommend that when we're doing this, you will circle your primes because those are the only ones I want to look at. Like I don't want to accidentally use the 6 that's in there because I got 2 and 3 from the 6. I broke that down. So circle all your primes. And then you're looking for pairs. Okay? I like stupid ways to remember things. So I always think about it as you're like going on a date. So you and your date, the 2 of you together, when you go out on a date, you are one couple. Okay? So like I have 2 2's. But when I bring them outside, it comes outside as just a 2. Now, the mathematical reason for that, what is 2 times 2? 4. What's the square root of 4? It's 2. That's why it happens that way, but I like stupid ways to remember things. Okay, so the 2 of them together come out as one couple. So just one of them comes out when we do that. Any singles? Leftovers, right? They're the leftover pieces. Where do you put leftovers? After you go to a restaurant, you bring your leftovers home. Where do they go? In the fridge, right? So you take your leftovers and put them inside, in the fridge. They go inside, and then they're going to multiply together to give you the 6. So grab your calculator real fast. type in square root of 24 and hit equals. If you have a graphing one, it's nice. You can see both of these side by side. So type in square root of 24. Is it a lovely decimal? Yeah. All right. Then type in 2 times the square root of 6. It's the same thing. It is just simplified. The same way like 5 over 10 and half, they're the same thing, right? They're both 0.5 if you would type in their decimals. Same idea. This is just the simplified form of this. Yeah. Yep. No matter what my numbers are, you're pulling out pairs. And that's what we're going to practice today. Okay? All right. So, number 1, square root of 32. Is that perfect? No. 36 is perfect. 32 is not. All right, so since it's not perfect, we'll do a factor tree. Now, some people get all up in arms about how people break these things down. It does not matter. Some people like to divide by 2 until they can't divide by 2 anymore. Totally fine. Some people are like, no, I want to find bigger numbers and yada yada. It doesn't matter. You're going to have the same number of numbers when you're done, so it doesn't matter. So I'm going to go 2 and 16. 2 is prime, so I'm going to circle it. 16, I know that's 4 and 4. Okay, neither one of those are prime, so I got to break them down. 4 is 2 times 2. And then the other 4 will break down to 2 times 2. All right, so you're going to keep breaking down. Now, if you went 2 and 16, and then 2 and 8, and then 2 and 4, and then 2 and 2, that's fine, okay? They keep breaking down until you get the same numbers. Sometimes they just get really long versus some of them get wide, depending on how you did it. All right, but we are looking for pairs. So I got a pair of 2s, right? And they come out as just 2. Do I have another pair? Yeah, I got another pair of 2s. It also will come out. Where do we put leftovers? Leftovers go in the fridge? Inside? What should I do with these? Multiply them. Yeah, see the dot? We're going to multiply this. So 4. I love stupid ways to remember things. Honestly, that's what'll make you remember it, right? If I strictly talked boring math talk to you all the time, would you guys remember everything I said? Yeah, it would put you to sleep, right? The weirder the things I tell you, the more you pay attention, because you're like, what is she going to say today? Like, she's crazy. All right, number 2. Radical 54, square root of 54. Is it perfect? What? No, it's not. Right. I know it's not perfect, so if you type it in your calculator, you get a decimal. So it's not perfect. So what do you multiply to get 54? 6 and 9? Neither which of those are prime, so I'm going to keep going. 6 is 2 times 3. 9 is 3 times 3. Okay, so we're looking for pairs. Do we have a pair of anything? Yeah, we got a pair of 3s. So they come out as just 3, right? They come out as one couple, just the one of them. And what leftovers do we have? What am I going to do with the 2 and the 3? We're going to multiply. And it's going to become a 6. So again, show of hands, how many of you have learned this before? Oh, way more hands went up that time. Okay, good. Is this how everyone has learned this before? Yeah? Yeah. The other way, if you don't want to hear this, that's fine. But the other way that people have learned this is you look for what perfect square goes into it. So you'd have to be like, all right, I know 9 goes in there. So you're like, okay, that's square root of 9 times the square root of 6, right? That's still 54. The square root of 9 is 3, and then I still have radical 6. That's how I learned it. Like, I always had to look for the perfect squares. But if you didn't look for the biggest perfect square, then you had to keep simplifying over and over, and it was a nightmare. So I find students are much more successful doing it this way. All right, what about number 3? Is that perfect? No. All right, so let's do a factor tree. 4 and what? 4 and 52. Is that what you said? 56? This is what I get for listening to other people, right? I should just do it in my head. Oh, I'm sorry. I thought you said 52. That's why when I repeat, it means I didn't hear what you said. All right. And then 4 will break down, right? 2 and 2. What about 56? All right, and then that's 2 and 7. And that's 2 and 2. For them to be pairs, do they have to like come from the same branch? No, they can come from anywhere, right? Anywhere, any of the numbers that you've circled. All right, what pairs do we have? Ooh, good. So I have a pair of 2s, another pair of 2s. Where do I put leftovers? In the fridge. So 2 and 7 will become 14. And then the 2 2s up front, that's 4. Radical 14. Anyone ever tell you to put your leftovers in the fridge? In math class, has anyone ever taught you that? Put your leftovers in the fridge? All right. What about number 4? How is that different? It's already got some number outside. Do I worry about that when I'm doing my factor tree? No. It's kind of like you're going on a double date and they're already at the restaurant before you. Okay? They're just kind of sitting there, they're hanging out. I'm kind of ignoring them for the time being until like we actually go out on our date to meet them. So, square root of 48. All right, so 48 we know, I'm going to go 2 and 24. I'm totally the 2 person. I divide by 2 all the time. Main reason I do that is because it's easy mental math for me to divide by 2. All right, so 2 and 12, I'll stick with my 2 pattern here. 2 and 6, 2 and 3. All right, what pairs do we have? Yeah, I got a pair of 2s there. Another pair of 2s. Leftovers in the fridge. Yep. This one's just already outside, so we can just bring it down. If you said 4, yep, you can multiply the 4 by it. You can bring it down and multiply them here. It doesn't matter. So 3 times 2 times 2 is 12, and then radical 3. Yeah, that look, you can't forget the people you're meeting on your date, right? They're already there. You got to let them join into the fun too. So you're all together. What about number 5? There's a negative number. Does that matter? No, it's just the people you're meeting are very negative people, apparently. Right? It doesn't matter. It's the same idea, same concept. Right? So we'll do our factor tree on the 108. So 2 and 54. 2 and 27. I had a student a few years ago that was very much into like divide by 2 all the way. And then they would get to something like that and they'd be like, I guess I'm done. Because 2 didn't go into 27. Like they truly didn't know what to do. Yeah, it'd be 3 and 9 right there. Yeah, I just was very comical. Like they were like into it. Like every time tell me what it was divided by 2, and then they were like out. They didn't know what to do. All right, so looking for pairs. What do we got? Got a pair of 2s. We got a pair of 3s. Leftovers in the fridge. What do I do with the negative 5 out front? He's coming down, right? We're meeting with them. So what do I do with the negative 5, the 2, and the 3? Multiply them, and what do we get? Negative 30, and then radical 3. Nice. Why don't you guys try number 6 on your own? All right, last problem here, guys. So first thing, factor tree. Some of us need a little help with our basic math here. I'm going to go 6 and 100 only because that's really easy when it's 600. 6 and 100. So 2 and 3. We'll go 10 and 10, 2 and 5, and 2 and 5. Now, yeah, when I have a number like 1,200, people panic. I'm like, it's 12 and 100. Like, if you just read the number. But it's fine. Like, you should still end up with the same number circled as I did. So it really doesn't matter which way you go. All right, so looking for pairs. I got a pair of 2s. I have a pair of 5s. Yep, leftovers, they multiply back into the fridge. And then don't forget you were meeting somebody, so they're already out there, the -4. So -4 times 2 times 5 is -40, and then radical 6. Yeah. Now, one thing I noticed walking around is many of you you don't cross off your primes as you use them, which is fine if you can kind of keep all that straight in your head. But if you guys have noticed on every problem, I cross them off. Why? Yeah, I know I've used them because I've seen students use them more than once, or they thought they used it and they didn't, so then they didn't put it down. Somebody in here didn't circle one of them, so it didn't get used in their answer. So just be careful, okay? I've just found it's easier if I kind of cross them off. That way I kind of know what's going on with it. All right, questions on simplifying radicals? All right, we're going to stop there for today. All right, you do have an assignment to practice some of this, so then you have the rest of the time to work on that.